All right, so today we're going to be building on what we did with the synthetic division in 5.3, and now we're going to be using synthetic division as kind of one of our steps in being able to factor polynomials completely. So there are a couple theorems that are really important in this section, and some of them they'll actually ask you for directly, but they'll ask questions related to all of them on your quiz. The first is the fundamental theorem of algebra, which tells us that a polynomial of degree n has exactly n roots, counting the roots that repeat. So we talked about when you had a perfect square trinomial that solution appears more than once. If it appeared twice, we would count it twice. If it appeared 3 times, we would count it 3 times. So a polynomial of degree 5 should have exactly 5 roots. Now, they may not all be unique because some of them might be repeats, but they might all be unique. But that is the most that they can possibly have. So if it's degree 3, it cannot have 4 solutions. 3 unique solutions is the most that it can have. The rational root theorem, they'll definitely ask you to do this on the quiz, and it says that if a polynomial has integer coefficients, so this doesn't work if the coefficients are decimals or fractions or square roots or anything like that, but if it does have integer coefficients, then every rational zero, so again, that doesn't include imaginaries or square roots, but all the rational zeros take the form p over q, where p is a factor of the constant. So it's very important that you know which one is p and which one is q. P are factors of the constant. Q are factors of the leading coefficient. So make sure you know that it's in that order because they may try to trick you and put it in the other order. So just pay attention, and I'm going to show you how to use that right here. So if we're looking at this polynomial equation, the constant is -3. And so P are factors of this. The leading coefficient, in this case, it is in standard form, so leading coefficient is always the coefficient of the one with the highest exponent. The leading coefficient is 2. So those are going to be my Q factors. So factors of -3 are 1 with -3 or -1 with +3. My leading coefficient is 2. Factors could be 1 with 2 or -1 with -2. So what we end up doing when we do P over Q, P are the factors of the constant. So we have both positive and -1 listed, both positive and -3 listed. Q, we have both positive and -1 and positive and -2. So what that means is that P over Q, you take each individual P and combine it with each individual Q. So plus and minus 1 here, plus and minus 1/2 there, because 1 over 1, 1 over 2. Now I'm going to do 3 over 1, and then 3 over 2. Now again, these are just the possible rational roots. It does not mean that all of those are actually roots. Because this is degree 3, the most roots that it can possibly have is 3, and we have 8 possibilities listed here. So they're not all roots, but these are the only possible rationals. So it would be impossible for this polynomial to have a root of 2, for instance, because it's not in the list. So this is a quick way, when it asks you for that multi-select, which of the following are possible roots, this is what we would do. Now we're going to talk about the steps to actually find the roots of the polynomial. Now, Algebraically, this would take forever because we would have to test like all 8 of these possibly, unless we got lucky and found, one of the right ones on the first try. So we're not going to do that. We're going to use our resources and graph the polynomial first to kind of give us a choice. So we're going to use this exact same equation for our first example. And the first thing we're going to do is we're going to graph it. So if I go over to my Desmos graphing calculator and type in this equation, so y equals 2x cubed, and then was 7x squared, 2x minus 3, so plus 7x squared plus 2x minus 3. All right, and what we are going to do here is we are now going to look, and we're going to look for what appear to be integer X-intercepts. So if you need to like zoom in so you can see a little bit better, these two, when I hover over them, I can see -3, 0, -1, 0. This one says 0.5. That's not an integer, so that's not what we're looking for here. So we want to start with one of these. It does not matter. And if you're using a handheld graphing calculator, let me just show you that real quick as well. Let's go back and graph this. So if I do the same equation, 2x cubed plus 7x squared plus 2x minus 3, and I graph it, you can kind of tell when the graph comes up that it looks, about the same, like maybe -3, -1. Because it doesn't have the hover over, the way that you can check it is by pressing second graph and looking at the table. So if I scroll, and I need to change my table step here. I don't know why that's being funky. Okay, let's go. Sorry, I have to do the actual table set here because it's not doing what I want to here. But there we go. So now if you look in the table, I can actually see a y-coordinate of 0 here, which is confirming those exact same ones. So what we've done is we've made a guess. So we come back and we've done step 1. So we found integer X-intercepts. In fact, we found 2 of them. We only really need 1 of them to start with. So we're going to now use synthetic division to confirm one of those roots. Remember also that roots 0 and solution all mean the same thing. So when you see that interchanged vocabulary, keep in mind that they all mean the same thing. So I'm just going to start with the -3 because it was the furthest on the left. So if I set up a synthetic division with the -3 on the outside, and then my coefficients here, so 2, 7, 2, -3, and bring down my first one, multiply the outside times the bottom, that gives me -6, add the column to get 1, -3 times 1 is -3, add the column to get -1, -3 times -1 is +3, add the column to get 0. This is the important thing. It's confirmed if the remainder is 0. So if it's not, you either need to look back at your graph to see if you typed the equation incorrectly, or you need to check your setup of the synthetic division. Perhaps, you needed a 0 as a placeholder and you forgot it or something. But if it is indeed a root, you're going to get 0 as my remainder. So what this has just told me, this is algebraic confirmation that x equals -3 is a root. So I found one of them. Remember, according to the fundamental theorem of algebra, that because this is degree 3, I should have 3 when I'm done. So I did step 2. Now step 3, I'm going to solve the quadratic equation that is the quotient of my confirmed synthetic division. So this right here, the quotient, remember my original was degree 3, so this is degree 2. 2x squared plus 1x minus 1 equals 0. And so now what I need to do is I need to solve this. So either by factoring or the quadratic formula, any of those. I always try to factor first just because I think it's faster. So since this is a 2, the only possibilities are 2 and 1. So 2x and 1x have to go in the front. Because this is a 1, I know these are both 1s. And because it's negative, I need one of them to be a plus and one of them to be a minus. So plus, minus, check it always when you're factoring. If I do the FOIL, this gives me 2x minus 1x, which is 1x. So this is correct. It is factorable. So then set each of these factors equal to 0. And solve them individually. So here I would add the 1 first, 2x equals 1, and then divide by 2, x equals 1/2. Here I would just subtract the 1, I get x equals -1. So now I have found and proven 3 different roots, or 3 different solutions, or 3 different zeros. It's degree 3, so I know I've found them all. And so a lot of times on the quiz, it's going to give you a multi-select. It'll ask you to choose which of these are roots or are solutions. Remember, they don't have to list all of them for you. So maybe they only list, these 2 and then a whole bunch of other ones that aren't right. You don't always have to pick, the same amount as the degree. So make sure you actually do the work to find the roots instead of just guessing. All right, so we're going to try that step process again here with B. We have x cubed minus x squared minus 19x plus 4. So first thing I'm going to do is I'm going to graph it. And I'm going to use the Desmos this time because it seems like when I've worked with a lot of you, that seems to be your preference. So let me pull that up here. All right, so I'm going to type in that equation as we had it. So y equals x cubed. And then we had minus x squared minus 19x and then plus 4. So here, clearly I can't see the whole shape because in our recent lessons we know what a cubic should look like. So I zoom out so that I can see a little bit better. And when I look at this, I see, okay, this guy, it's telling me is, a decimal. So that's not going to work. Same with this one. This one, however, is an integer. So we have found one winner at -4. So then I go back, because that's step 1. And since -4 is my winner, I'm going to put that on the outside and then copy my coefficients down. So 1x cubed, -1x squared, -19x, and then 4. So put in my remainder separator and my horizontal line and start the process. So I get -4 when I multiply, -5 when I add. Here when I multiply, I get +20. I get 1 when I add. -4 when I multiply, 0 when I add. So yes, I have confirmed, because the remainder is 0, that x equals -4 is indeed one of my roots, or one of my solutions, or one of my zeros. Now I need to solve what's left here. So original was cubic, so this is quadratic. X squared minus 5x plus 1 equals 0, because I'm solving it. Now, this guy is not going to be factorable because there are no factors of 1 that add to -5. So because I know it's not factorable, that means on this one I'm going to use the quadratic formula. So x equals the opposite of b, so +5, plus or minus the square root of b squared. -5 when I square it is 25, minus 4 times a, which is 1, times c, which is also 1, all divided by 2 times a. And then I simplify. So here I've got -4 times 1 times 1, which is -4. 25 minus 4 is 21. And then on the bottom I've got a 2. Now 21, if I were to try to break it down, it's 7 times 3, but there's no pairs, so there's nothing I can do to simplify this. So that would mean that one of my roots is 5 plus radical 21 over 2, and the other is 5 minus radical 21 over 2. And so these are my 3. Degree 3, 3 roots, 3 zeros, 3 solutions. All right, now the last part that goes with this is the factor theorem. So the factor theorem says that a polynomial f of x has factor x minus k if and only if f of k equals 0. So what this says is k is a root, or k is a solution, or k is a 0. So they're just reminding you that if k is the root, that x minus k is a factor. So what that tells us, for example, is if x equals, we'll just use this one, 4 is a root, then x plus 4 is a factor. So we've got a bunch of those here. When we have the fractions, when it's like this, you have to like go and work backward, because what you're trying to do is to get back to this. We don't actually use like x minus 1/2. We would multiply by the 2 and then subtract the 1. So x equals 1/2 is the root, 2x minus 1 is the factor. So sometimes we will be asked to write the complete factorization as opposed to being asked to find the roots or find the solutions. Now we're going to start out the exact same way. So I'm going to take this equation and I'm going to graph it first. So x cubed minus x squared plus 4x. And then was it a minus 4? Yes. So change this guy to a minus. All right. And so I can see here my very skinny cubic only crosses the x-axis once. That's okay, because that 1 does happen to be an integer for us. So x equals 1 is my root. So that means I'm going to put 1 in my little box. And then 1x cubed, negative 1x squared, positive 4x, negative 4. Bring this down. Multiply to get 1, add to get 0. Multiply gives me 0, add gives me 4. Multiply gives me 4, add gives me 0. So that confirms it. I know that x equals 1 is a root, which means x minus 1 is a factor, because it's asking me for the complete factorization. So in order to have the complete factorization, because these are not going to be traditionally factorable, I now need to look at this guy and say, okay, my original was cubic, this is quadratic, so 1x squared plus 0x, I don't need to write that if there aren't any, plus 4. Now, you can do this one of two ways. If you know how this quadratic factors, then go ahead and factor it, and you don't have to solve. But sometimes we're not going to know how it factors because this actually isn't traditionally factorable. But it is a very easy one to solve because, and I guess I should have put up here, or square roots, because this is most easily solved by taking square roots. So if I get the x squared alone and square root both sides, I know x equals plus or minus the square root of -4. Remember, the negative means that I'm going to have i's. So here, I know that I have x equals 2i as a root, which means x minus 2i is a factor. And I have x equals -2i as a root, which means x plus 2i is a factor. So when it asks for the complete factorization, here's a factor, here's a factor, here's a factor. It is degree 3, so it should have 3 factors. It doesn't matter that some of them are imaginary. You're going to have some like that on your quiz as well. Some of them could be all whole numbers. If you got down to this quadratic and just like we did here, it factors. If you got to this, then you would just say, okay, x plus 3 times 2x minus 1 times x plus 1, and that would be the end. But you will have some that have imaginaries, so I wanted to illustrate that. All right, make sure you do your practice and make sure you ask if you have questions.